Alright, welcome to the video for lesson number 3 in chapter 4 for trigonometry. So in today's lesson we learned about the extension of trigonometry values past 360 degrees. So we're going to have some angles here that are slightly larger than 360. They still end up being in a quadrant. In class we talked about how they kind of just keep going around in circles, and we eventually will get to an angle that's within one of the quadrants that we want to see. So let's start with the first one. So for the first one, we see an angle of 480. So as soon as we see an angle that's bigger than 360, we want to take 480 and subtract away the 360, and you're going to keep subtracting away 360 until you get an angle that's within the right domain. So if I do 480 minus 360, I get 120. So that tells us that this is a quadrant 2 angle. And it wants us to calculate the cosine of this angle. So since 120 is in quadrant 2, I know the reference angle is going to be equal to 180 minus 120. So the reference angle is 60. So essentially what we know from this is that the cosine of 480 is equal to the cosine of 120, which is equal to negative cosine of 60. Now the reason why it's negative is because it's in quadrant 2. And we either know that because it's the x value or because of all students take calculus. And then it wants us to calculate the actual value here. So to calculate the value, you need to know your special right triangles. So 30, 60, 90. 60 cosine is going to be 1/2, so that's negative 1/2. You can check that right in your calculator, type it in. You'll get 480, 120, or negative cosine of 60, all will give you the same answer. I do the same thing for sine. Since we're in quadrant 2, we know sine is positive. And then if we use our ratios, we get the square root of 3 over 2. Not too bad. See how it's all kind of fitting together, I hope. All right, so for number 2, we kind of have just a mixture of questions, just determining and practicing what all this is. All right, so I'm just going to give you the answers here. So one of the things that we have to be able to do for this is really understand your triangles. So off to the side here, I'm just going to draw the 2 triangles so that we have them. So you need to have your 30, 60, 90 triangle. I don't know about you, but I'm starting to get bored of drawing this out, right? Let's just memorize them. That'll make everything easier. And I just got to grab my calculator so I don't make any mistakes. I don't want Elena to find any more of my mistakes here. So let's see. So for the first one, for 690, 690 is too big. So if I subtract 360, you get 330, which is in quadrant 4. 330 has a reference angle of 30 degrees because it takes 30 degrees to get back to 360. Because I'm in quadrant 4, I know the cosine is positive, and the cosine of 30 is going to be the square root of 3 over 2. Since I'm in quadrant 4, I know the sign is negative, so I'm going to get negative 1/2. 1560 is way too big, so if I subtract 360 a bunch of times, I get 120, which is in quadrant 2. 120 has a reference angle of 60. And in quadrant 2, cosine is negative, and the cosine value of 60 is 1/2, so negative 1/2. Sine in quadrant 2 is positive, so that's going to become the square root of 3 over 2. 855, so if I subtract 360 a couple times from that one, I get 135, which is in quadrant 2, which has a reference angle of 45. And when you take the sine or cosine of 45, remember you're getting 1 over radical 2, which can rationalize to the square root of 2 over 2. We did that a few times in class. Look back in your notes if you're unsure of the process. And for both the sine and cosine of 135, we're going to get the same value, but one of them's positive and one of them's negative. Because I'm in quadrant 2, I know the cosine is negative and the sine is going to be positive. The only quadrants where sine and cosine are the same signs are in quadrants 1 and 3. 1, they're both positive. 3, they're both negative. We also talked about negative numbers today. So if I take negative 330 and add 360, I get 30, which is in quadrant 1. Any angle in quadrant 1 is its own reference angle. Since I'm in quadrant 1, both sine and cosine are positive. We kind of just talked about that. The cosine of 30 is square root of 3 over 2, and the sine of 30 is 1/2. So we could see, even though we're in different quadrants, we have different angles, they're all kind of the same numbers, just repeating themselves over and over again. So if I do negative 510 plus 360 a few times, I get 210. 210 is in quadrant 3. This is one of those cases where sine and cosine are both negative. 210 has a reference angle of 30. So if I have the same value that I got here for the last one, these expressions are going to be the same. They're just both negative. And again, I could get them from that triangle. So using the triangles is very important here, right? If you are in this class at this point and you have not memorized these two things, you are in trouble. Okay. The last one, negative 135. If I add 360 to that, I get 225, which is in quadrant 3 also. So again, I know the two answers here would be both negative. 225 has a reference angle of 45. I've already evaluated sine and cosine of 45, so I already know the ratio. I just have to put the correct signs in there. So one of the things that we're leading towards here with all of this is being able to eventually, not anytime soon, graph these, and we'll notice that a lot of the signs, the values are going to keep coming up same points over and over and over again. So for number 3, it says to evaluate all these special values. You could literally type every single one of these in your calculator and get an answer. That's not what I'm interested in you doing for this. I wanted you to actually go through and use the unit circle and practice using that skill so that we know where everything is. It's important, especially for those of you that are planning on taking pre-calc next year, which should be all of you. So let's just draw out the quick unit circle here. So here is my X and Y axis. Draw the unit circle. And let's identify the 4 points that are actually on the unit circle. So on the unit circle, this is the point 1, 0, 0, 1, negative 1, 0, and 0, negative 1. I also know at each one of those locations we're at a degree value, so 0 degrees, 90, 180, and 270. And also I know any point on the unit circle is the cosine of the angle, comma, the sine of the angle. So if I want to know the cosine of 90, well, that's just the x-coordinate of the point at 90 degrees, so that's 0. The sine of 90 is just the y-coordinate at that point, so that's 1. 360 and 0 are the same. So the cosine at 360 is 1, the sine at 360 is 0. At 180, the sine or the x-coordinate is 0. The cosine or the the sine is the y-coordinate, the cosine is the x-coordinate there. 270, the sine is the y-coordinate and the cosine is the x-coordinate. 450, well, that's big, so let's do 450 minus 360. Well, that's the same thing as 90. Well, the sine at 90 was just 1. 0, cosine value is the x, so that's 1. Negative 90, that's the same as 270, and the sine at 270 is negative 1 because it's the y-coordinate. Negative 270, well, that's the same as positive 90, and the cosine at positive 90, well, that's 0. Notice we can do all of this without our calculators. It's just essentially knowing where those 4 locations are. Now, one of the things that's important for you to understand is, yes, you can find all these answers in your calculator, but if you know these off the top of your head, it'll make sketching and graphing sine and cosine functions really easy when we eventually get to it. I know I keep talking about graphing, but that's where we're getting to. Number 3 talks about this girl named Jane and how she talks about reference angles and all this stuff. And it says that she thinks that the reference angle for negative 765 has a measure of 45. And that cosine of negative 765 is the same as that. So is the sine of 45. Why is she or is she not correct? So the first thing I want to do is figure out what is the reference angle and what quadrant we're in. So if I do negative 765 and I add 360 a few times, I get 315. So the cosine of negative 765 is the same thing as the cosine of 315. Same thing for sine. Now 315 is in quadrant 4. Quadrant 4 angles are going to be positive for cosine, but negative for sine. And the reference angle for 315 is 45. So she's correct for this cosine part, but she's incorrect for this sine part. The sine of negative 765 and sine of positive 45, they're going to be the same ratio, but one of them is positive and one of them is negative, so they're not going to match. So she's incorrect. And the reason why is because the sine of negative 765 is negative because of it being in quadrant 4. Number 4, let P be a point 2, 3, and theta be an angle formed from the x-axis and the origin. It says Ryan claims that the cosine is 2 and the sine is 3. Why is he incorrect? Now, we've been saying for the last day and a half that any point on the unit circle has an x-coordinate of cosine and a y-coordinate of sine. So you might be saying, I don't understand why he's incorrect. Well, the reason why is it doesn't actually say anything here about this being on the unit circle. So because of that, I actually have to determine if this point is on the unit circle or not. So let's see. So 2, 3 is in quadrant 1, so that makes it kind of nice and easy. So here's my point 2, 3. If this is on the unit circle, the hypotenuse of this triangle should be 1. Well, if I do 2 squared plus 3 squared equals c squared, I'm going to wind up getting 13 equals c squared, or c equals the square root of 13, which is approximately some decimal like 3 point something, 3.606. So because the hypotenuse, or the radius of this circle that this triangle is created by, is not 1, I know this is not on the unit circle. So we can say point P is not on the unit circle. So the x and y coordinate are not cosine and sine. Now, to make it so that they are, what we could do is divide each of these values for x and y by the hypotenuse. Because if I divide all of the sides by the length of the hypotenuse, I'm making it so that it is a unit circle. So let's do that as an extension kind of thing. You don't have to do this, but this kind of will help you better understand what's going on. So let's talk about this triangle. So this triangle has a side of 2 and 3 and a square root of 13. I want to make it so that it has a side of 1. Theta is going to stay the same, meaning these are similar triangles. So what can I make the other two sides? So I have to divide by the square root of 13 to make 1, so this becomes 3 over the square root of 13, and this becomes 2 over the square root of 13. That becomes a similar triangle. Now because this hypotenuse is 1, now it's on the unit circle, so that means point P could have coordinates of 2 over the square root of 13, comma 3 over the square root of 13, if we left them unrationalized. If we wanted to get really crazy and rationalize them, we could. So we'd get this and this. Again, I'm not asking you to do that for this question, but we could, right? So that's one thing that's nice. Hopefully these videos are helping you, especially for this chapter. I think they're kind of useful. I do apologize. There's been a few mistakes so far. Just let me know if you find any, and good luck.